Welcome to the Flare Build Podcast. Today's guest is Keith Smiley, a mobile tooling engineer at Lyft. He's currently the lead maintainer of Rules Apple and Rules Swift, and an active contributor to the Bazel community. Now over to your hosts, Tatiana and Zach, the co-founders at Flare Build, the first consultancy and product company focused on Bazel.
Keith, welcome to the Bazel Show. It's great to have you here. And if you want to, in your own words, maybe give us a quick update on what you've been up to recently.
Yeah, thanks for having me. Yeah, so I guess I can start with just a tiny bit about me. I am a mobile tooling engineer at Lyft. I've been at Lyft for almost 6 years. So I've been able to see a lot of evolution in our tooling over that time as the mobile team has grown a lot as well. And then kind of in the last few years, I led the migration on to Bazel for iOS and kind of helping out a little bit on the Android side as well these days.
Okay, cool. And where are you located these days?
Yeah, I live in San Francisco, which is where the main Lyft office is, even though that doesn't matter so much these days. But yeah, still like it here.
Right. And you said you just got back to San Francisco for being out of town. So just in time for brunch, huh?
Yeah. Yeah. My parents live in the San Juan Island. So it's a very nice place to vacation to for a few weeks away at a time these days.
Cool. So of course you mentioned the migration to building with Bazel at Lyft, which, folks in the community are pretty aware of that because you guys have talked about it, but I think definitely that's something we should dive into a bit more. So for folks that have missed the other talks that you've done, do you want to give us just a quick overview of what the journey to building the Lyft app with Bazel was?
Yeah. So we kind of went through, I think, a similar path to a lot of the companies that end up with huge mobile engineering teams. So, we kind of started hitting what we felt to be pretty difficult to solve problems in kind of the standard tool chain or what most folks are using. And, we were still continuing to grow. So, it wasn't just the problems we were facing those days, but it was also how much worse is all this going to be in a year as people, continue writing a whole bunch more code and there's a whole bunch of new features and new apps and stuff like that. So that kind of led us to looking around for other options. And, at the time, Bazel was still pretty young, but there was some precedent in the iOS community from Pinterest for migrating. I think they were the first real big name to migrate. And I think it was probably a year later that we kind of started that.
When was that?
I guess we probably started towards the end of 2018 to migrate.
Okay. Asian times and Bazel time.
Yeah. So, it was pre 1.0, I guess, is a good indicator. But, the iOS rules from the Google side were pretty complete and polished at that point. I think they were the first rule set that was written in Starlark. There's a lot of pieces the Objective-C stuff that's still in the Bazel core, but all of the logic around how do you actually package an app and stuff was all in this separate Starlark repo, which was much nicer to work with. So it actually seemed like a pretty good time to move. It seemed like there was a lot of good support from Google. So we were feeling pretty good about it at the time. The Swift rules were separate as well. So yeah. But, we spent the next, I guess, kind of while getting our code, just building with Bazel and kind of figuring out a lot of kinks that were, specific to our project, especially since, at the time, since fewer folks were using the rules, a lot of the rule kind of functionality was best effort from Google for kind of what they needed. So we had a very different type of app at that point. We had purely Swift. We still do, but Google at that time didn't really have as much. And so, we were hitting a lot of unique issues specific to how we build apps versus how Google built apps. So we contributed a lot of that stuff back and, I think made a lot of good progress for the community there. And then, kind of the longest piece for us was more on the IDE integration side, which is kind of a hot topic in the iOS community, trying to make stuff work well with Xcode. But yeah, so that kind of lagged on for a bit, but we've been on Bazel, I guess, for almost 2 years now, and it's going pretty well at this point.
It's great. I don't know if you ever shared any top-line metrics on the end result of how you might measure developer experience or CI times or anything like that?
Yeah, I'm sure I've mentioned some in some various talks. When we migrated originally, our goal was really just to like keep parity. And then the assumption was that because Bazel is more flexible and open source and stuff like that, we'd be able to start kind of iterating on improvements. And I think that pretty much worked out for us. So when we switched over, it was 1-for-1 kind of build times. But then, we stood up a remote cache and stuff like after that. And we worked on some bottlenecks in the rules and stuff like that to drive, I guess, a lot better build performance. I think the most impressive metric is just like clean build time with and without cache for folks. So yeah, when a developer like pulls the main branch after working on a feature, merging a feature or something like that, like there's already cache waiting for them, and that cuts clean build time from like 20 minutes to 2 minutes or something. So I mean, that kind of metric I think is normally the most impressive one. So we saw a lot of those gains that I think people promise or whatever. So I think the Bazel really fulfilled itself there.
Mm-hmm. Great. Yeah, it's good to know. Yeah, one other thing we talked about previously was during that migration, you also had created some tooling to generate your build files. Maybe that's something worth describing briefly.
Yeah, so I started kind of alluding to, we went through a similar path as a lot of companies. So, one of those steps in my mind at this point is that companies stop checking in their Xcode projects, which are notoriously difficult to merge between lots of developers. And you can't really tell, like, when someone adds a target and you're looking at kind of an opaque plist, it's like diff, it's really hard to tell what they were actually doing. So we moved to Xcode Gen, which is an open source tool in the community. It's really fantastic. We still use it, definitely recommended. Where, we started generating our projects. So instead of like just opening a checked in one, developers were already running some command that kind of did pod install normal dependency stuff. So we just started kind of generating a project as part of that. At the time, Xcode Gen was a little bit younger, so it was a little bit less flexible. So we actually wrote like a kind of a little wrapper on top of it that let developers kind of define their modules in a very kind of restricted public API, which is very similar to how you'd think about Bazel rules. I mean, at this point, Bazel was on our radar, even though at that time we hadn't decided to move to it. So it was still like nice inspiration for that. So that kind of let us, make sure that developers were kind of playing within some guardrails to make sure they weren't doing really crazy project configuration stuff. And then it also let us, generate the Xcode project. So when we got around to working on Bazel, we were actually able to take that same definition of the same tool and just spit out build files instead. So for a long time when we were testing our Bazel migration, we would run that tool to spit out the build files. They weren't checked in, but we'd like do that on CI to validate that everything was still working well with Bazel. And then eventually when we actually cut over, we actually checked that stuff in. But, theoretically, I guess, we probably could have still done a lot of that generation given the kind of conventions that we had. Like, for example, we enforce that everyone keeps their sources in a directory called sources or whatever. So if you really wanted to generate the build files instead of handwriting them, that would be something. I think it's kind of nice to actually see the handwritten diff in a lot of cases because it gets the intent across. Like when someone adds a dependency, I think if that's generated code versus like intentional, it makes people pause to think a little bit more, which I think is valuable. And since then, we've probably added a few features that aren't easily generatable from sources at this point. But that was a really nice way to migrate without having to like manually translate everyone's build configs.
Sure. Yeah. Xcode Gen is a great tool. And a lot of the folks that we work with have very similar background. And it's a common pattern. I think we've worked through very similar situations. Yeah. Was it actually the majority of the project definition in Xcode Gen YAML config or JSON config, or was it in this other configuration kind of on top of that specific to your tooling?
Yeah, so actually before that step, we had extracted kind of everything out of the Xcode projects themselves into XE config files. And that was just like even before that, just to try to make more sense of it. Because again, with project file diffing, it was really difficult. So this way we kind of made sure that like no settings were ever checked into the Xcode project itself. So when we switched to Xcode Gen, we actually made it ignore like all of its default configs because we already had all of that defined in like other config files, which I think was really nice for like code reviewability and stuff like that too. So really the kind of module definitions that people had to maintain were pretty small. It was mostly just like a name and do you have a test target and stuff like that. Because like I mentioned, based on our conventions, you were already kind of enforced to use certain directories and have kind of some certain default settings. So those were pretty small and then everything else lived in those XE configs.
Mm-hmm. Okay. It's awesome. All right. So let's move on to talk about the current state of things at Lyft, your current challenges and what's on the roadmap for the iOS team at Lyft, because I imagine you're doing some pretty exciting things.
Yeah. So, I mean, definitely a lot of our projects still revolve around like improving developer experience and a lot of that still relates to builds. So, since we migrated, we've added a bunch more code, which kind of continuously like increases the challenges. And so we're still kind of like chipping away at incremental build times and other things like that, while also kind of looking into some of the bigger options for that kind of stuff like remote execution and trying to figure out how to get that to work. So we kind of have a lot of different like parallel tracks, but still very focused on how we can improve the developer experience as stuff keeps growing.
So obviously remote execution is a hot topic. And so, yeah, I would love to hear whatever you can share about how that's going and obviously the impact that some of the design issues that we've talked about in the past and the rule sets and things like that affect the project and what's on your radar for what you might need to change there.
Yeah, so we're currently like kind of in the evaluation stage of like a few different options for how remote exec would work. Like there's a lot of different services and stuff out there. The common theme I guess that we've seen so far is that even more so than we expected, like network performance just plays such a big role. And a big part of our goal is to improve the local developer experience. Like improving CI with remote exec, I think is a useful thing to us, but not as important, I don't think, as the local kind of iteration speed. Our CI just happens to be like fast enough. I mean, it won't be forever, but so far, like we've been okay with that. So we're much more interested in how we can improve that when someone like changes something kind of in the middle of the dependency graph and has to rebuild like half the app. And that takes, 10 minutes or something. We're kind of much more interested in that case right now. So network performance has been a huge problem, especially with everyone working from home. It's just kind of difficult to make sure you have like stable connections. So we're trying to work through that. And like part of that, of course, is trying to figure out how we can send less over the wire or something like that. But a lot of those, I guess, are still TBD. Yeah, on the rule side, I mean, there's, I guess the biggest kind of issue right now is just, it's probably pretty in the weeds, but there's this module cache that the compiler kind of implicitly creates when you compile some Swift or Objective-C, but in our case, we only really care about the Swift case. And what happens is, since that isn't part of the Bazel build graph, the remote execution service needs it, but we don't send it up, so then it has to reproduce it like every single time. And that kind of leads to a huge amount of overhead on like every single action. So there's a lot of work in the community, like both at Google and from the Apple folks in the Swift compiler itself around explicit module builds where you can kind of define all of your dependencies. And so none of that ends up being implicit, which seems really great. Still kind of unclear exactly what the UX for that looks like from the developer side. So we'll see on that, but kind of hoping that that ends up helping out here sometime this year.
Yeah, definitely looking forward to that. And even the network utilization you mentioned, I feel like a lot of that's just due to the iOS rules and like sending so much data back and forth like that. Yeah. Okay, cool. And
yeah, I wanted to ask about like remote cache. How does it work in Lyft? So basically, if you have like half of the team in Hawaii and half the team in San Francisco or something like this, right? Where do you have your remote cache?
Yeah, we're actually using a Google hosted offering for that. So I guess it's wherever they decide.
They place it.
Yeah. We haven't spent much time, honestly, like trying to performance test the cache in general. It seems like it's been pretty good. So we've been pretty happy with it without touching it much. I think that there's a luxury there of that part being managed a lot by Google. We do host other remote caches at Lyft outside of the iOS team, and those have definitely fluctuated a lot over time of how they work. And, different people have different requirements. Like one of the teams that uses it, everyone has a build machine at their desk in the office.
Yeah.
And so the remote cache is there too. And, even working from home, they SSH in and it's no problem. So I'm kind of happy that we're avoiding those problems right now, but we'll see how that plays out, I guess, with remote execution, since that changes the situation a lot.
So have you deployed something like Build Barn, like into your infrastructure? Is that something you can talk about?
Yeah, we've tried those in the past. I think I tried Build Farm first, which is the one on the Bazel GitHub org. I think it was started from the folks at Uber. And, a lot of these tools didn't start with doing iOS or macOS builds, unsurprisingly, because obviously Bazel is much larger in other communities. But so that's always been kind of a consistent challenge, just figuring out like what is broken because of that. There's a common theme of like, Xcode selection or whatever. That's a big issue, just the way that Bazel manages that. But even after that, of like what it relies on resource wise or something like that. So yeah, we're considering trying those again. I guess I don't really know what the state of those is. I'd love to hear if folks do. One of the team I was just talking about who has the local machines uses Build Barn for caching, but not for remote execution right now.
Interesting. Cool. Yeah, it's exciting to see the development continue on those tools. So we'll see how things evolve there for sure.
It seems like a perfect community tool. Obviously, like SaaS offerings make a lot of sense for this too, but I'm kind of surprised. We've tried a lot of the major open source like remote caches as well, and we kind of hit similar problems at some point. I guess not with Build Barn yet, but a lot of the caches assume there's only one instance and stuff like that, and that kind of causes problems. Like if it doesn't work on the biggest AWS machine, what do you do? That kind of thing. So
yeah. I think a lot of the stuff that's out there, for the most part, it's like a good reference implementation. It's good to see like how the remote APIs can look and what like a quick implementation might look like. But yeah, I mean, most of them are missing like an effective load balancer, for example. I don't want to name drop the libraries, but yeah, these things are, they're missing kind of like some of the most crucial pieces you'd need for horizontal scalability and high availability and anything like that. So yeah, that's a kind of a common issue. So yeah, hopefully the vendors can do something here, I guess. Okay. Well, yeah. So that's great. If there's anything else that you are interested in sharing on the CI setup for building with Bazel on iOS, I think that might be enlightening to some folks. Anything that you're interested in sharing about like just infrastructure and stuff like that. I think you have maybe some interesting info on the Mac worker farm that you're running and stuff like that might be useful for folks.
Yeah, so we host our own Mac Minis in some data centers like around the SF area, and that we kind of have for other reasons. So that was a nice thing for us to just be able to slide some Mac Minis in there. They're pretty small. They only take up a few racks. And so we host about 100 machines right now. And then we connect them to BuildKite, which is a great CI offering, and run them that way. So far, that's gone pretty well. I know there's a lot of obviously a lot of offerings out there for macOS CI support, but that's gone pretty well for us. I think it has some advantages in that we're not trying to be a CI vendor, so we don't really need to support all possible use cases. And what that means is it's like really easy for us to run on bare metal and not worry about pollution in the environment or anything, because we control like all the scripts that run on the thing, and it's all in one repo. Like we have a iOS repo that houses all of iOS code at Lyft, and so my team pretty much controls the scripts. So as long as you don't do anything outside of the normal kind of sandbox, you don't have to worry about that. And that lets us avoid VMs, which historically have had big performance impact on builds, although it sounds like it might be getting better, although we haven't tried that yet. But yeah, I mean, we do some interesting stuff, I think, from the Bazel build side. Unlike Linux CI, like we can't easily auto scale our hosted cluster. So that's kind of led us to be pretty conservative about only building what we need to over time. And we were actually doing this with that tool I was talking about earlier with Xcogen. We actually kind of built some not nearly as fully featured version of Bazel Query into that. So you could kind of query, given a set of files, what actually changed. But now we do that with Bazel, and that lets us do a lot of cool stuff. Like, if you change a file that only affects one app, we only rebuild that one app. We only run the tests that could be affected by your change, stuff like this. Something I think they've been doing at Google for a long time, but there isn't really a community tool out there to help do this stuff. So, but that's really nice. And for us, especially as we've grown, that's been a huge win, because if you actually make a change that affects everything, you can end up kicking off, 50 or so CI jobs in our infrastructure. Whereas if you only make a one app change, you can cut that in half or something. So that's been really helpful as we continue adding code.
Maybe we should dive in a little deeper on that. So for folks that don't know, like the naive approach is just telling Bazel to test or build everything using some sort of a wild card. And that seems like a good idea. I think the problem there is that even the loading and analysis phase can take a very long time on big projects. And then you can still end up doing a little bit more work than you need to if the disk is out of sync, and just like other little edge cases like that. So yeah, there's a pattern in the community of, there's a couple different ways people have solved this. Bazel itself uses a simple Git, a couple of Git commands that you can see. If you look at their repository, you can kind of see how they're like actually checking to see what packages or something like that at least had changes, and then they use those as the input to what they build. There's a tool from Tinder actually that's kind of like trying to codify a bit of this called Bazel Diff. And I think also definitely recently it was 2019 Dropbox had a talk about this. So definitely a lot of folks are looking at this. So I'm curious what your implementation looks like there at Lyft.
Yeah, it's pretty small. I mean, I would definitely love to have a community-driven implementation, but I was looking at Bazel Diff, and I think that one's definitely promising. It seems like a lot of folks are jumping on that, but we've been able to definitely do a lot of custom stuff for the way our project is set up. And again, going back to like conventions, we kind of enforce that all iOS related modules all start in this one top level directory. So it's like we only even do the query on CI against that directory. And if you change anything outside of that, we just assume we need to rebuild everything because it's not part of the normal build graph. But yeah, I mean, we just do a few queries based on that. So yeah, given the set of files from like the GitHub API, we'll do a query to try to get all the apps and all the tests kind of like up the tree from you. And then we do some other kind of, I think, interesting stuff on that. So like if you change a specific module, we'll actually run the tests for that module more times just to try to eliminate any flakiness that's being introduced. And we'll run like code coverage against only that bit as well, because, it doesn't really matter if you affect code coverage, or you don't really expect to affect code coverage up the tree, but it's useful to see for yours, which I think is a really cool thing to be able to do kind of based on all that querying as well.
Yeah. I like the code coverage thing. That makes a lot of sense. That's cool. Yeah, so I guess to wrap up the state of things at Lyft, are there any other future aspirations that are something that you dream of getting to, but you just haven't started on yet?
Yeah, I think a big thing that we talk about a lot in the iOS community is getting to like some nice version of dynamic linking, which solves a big problem that you see in iOS, where no matter like how much you change, the final like link step can be huge because you're kind of bringing all code together at once at the end because you want to ship this like statically linked executable. And we've hit a lot of problems with that over time. So we haven't been able to do that yet, but I'm still kind of excited to get that done because I think it helps like parallelize a lot more of this, which is perfect for remote execution. So you can like kind of farm out these links, and then that should overall help the kind of incremental build time for folks. But it's a surprisingly challenging one. I think we're getting there now, but there's been a lot of like little issues along the way.
Yeah, that's exciting. Definitely, yeah, we should sync up on that. I guess that actually brings up another question. Are you using an alternative linker for your developers that might be a little bit faster for local development?
Yeah, we do use the ZLD project, which is a big one that's been around. I'm not exactly sure what the GitHub org is, but I think if you Google about it, you can find it. It's definitely an improvement for us. I think it's like 25% improvement on our projects. So yeah, that's great. But it's still, our links, I think, are still 30 seconds or something. So it's still pretty significant. I think that we're better off from a lot of other folks that I've heard from who say that theirs are like over a minute or something. So, but yeah, that's still a long time to wait for minimal changes, like when you're trying to iterate on something as a feature engineer.
Yeah, and integration of that linker into your builds. Obviously, some of the other third-party rule sets I've seen have like a really easy, straightforward way to swap the linker out. What does that look like just using vanilla rule Swift?
So we're actually just kind of skipping Bazel for that piece, and we like pass the command line like -- link opt flag to set the linker with Clang's like f_use_ld flag. So we kind of skipped that bit. That doesn't work with remote execution. And yeah, the line Apple rules, I don't know if you remember what the GitHub org is there, but those have a rule for it that I think is the ideal solution. We just haven't gotten around to it, but we'll probably do that with remote execution.
Gotcha. The GitHub org is just line.
Okay, there you go. Yeah, they have a nice rule set with a lot of Apple rules, and they have a good implementation of the kind of ZLD integration that works right now with Xcode. So if folks are interested in that, that's a good place to look.
Yeah, I think this is a great segue to diving into discussion of the iOS rule sets. And so for folks that don't know, obviously in the last couple months, you've become one of the official maintainers of Rules Apple and Rules Swift. And in addition to having contributed quite a bit to that over the years previously. To kick things off, I guess I'd definitely be curious to hear what it's like being a official Bazel build rule set maintainer.
Yeah, it's been pretty interesting. So, I mean, the transition kind of happened because, Google was pretty resource constrained, like dealing with the open source contributions. So it was kind of like slow to get stuff in, and Google folks weren't really happy with it, and we weren't really happy with it. So we were able to kind of work out a proposal with the Google folks to kind of, transfer that over. And now a few of us are maintaining that from the community. It's been pretty great so far, I think. I think a lot of folks have, internal forks of the rules to kind of fix a few things here and there for their code base. So we've been trying to encourage folks to actually try to upstream those, and we try to figure out how to integrate them. So far, I think that's been working pretty well. I mean, I think that a lot of this stuff is more interesting in how it plays out in the long term, like how hard it is to kind of keep it maintained as stuff changes from the Apple side or whatever. I think so far, we've only had one kind of major release since we've taken that over. And so it hasn't been a major problem, but this stuff kind of compounds. So it can be more difficult to maintain, I guess, more features over time, especially as Lyft isn't using all of these features. So it's hard for us to verify them as well. But so far, I think that's been going really well. And we have like a wide variety of different projects testing everything that's happening, just with the other folks who are using it and contributing to it. So yeah, that's been great so far. The situation with this rule set is a little bit different than some of the others, where Google does still push their internal changes externally. And as the maintainers, we can decide whether or not we want to like cherry pick their changes into the kind of open source one and deal with whatever conflicts arise from that. So far, we've been keeping up with that really well. I think that that's definitely a nice thing because, the Google folks are often the ones to push out changes for upcoming Bazel compatibility things because, the Bazel folks have a roadmap internally and, it can require rule changes. So that's been pretty nice. Plus, they're implementing features as well that can be useful to the open source side and vice versa. They've taken some of the open source contributions and applied them internally too. So far, I think that's going pretty great, but definitely interested to see, as more folks kind of get into Bazel, we've been talking to a lot of companies lately who are interested in moving for iOS, definitely interested to see how the rules like work for them. But yeah, I guess that kind of relates to the other rule sets as well that we were just kind of talking about.
Sure. So yeah, I definitely want to get to talking about the other rule sets. But maybe before we move on, so in Rules Apple and Rules Swift, there's definitely, there's a lot of kind of hotly requested features, and we should probably check in on some of those and also just hear kind of about like what's on the roadmap and coming soon. So an obvious one that people have been talking about for quite a while is the ARM support for the M1 Max. So maybe just a quick status update there might be useful.
Yeah, there's a few kind of like separate problems there. So the first one was, can you even get a Bazel binary that runs natively on Apple Silicon? And the answer to that is now yes, which is great. Thanks to T from Line, who did a ton of the work there, as well as some of the Google folks. And then the second step is like, there's this problem that never before in Bazel, at least I don't think, maybe when it was still only internal, but I don't think that there's ever been a case where you've had the same architecture that it actually means two different platforms. And that's kind of the situation now where you have ARM64 meaning iOS device and you have ARM64 meaning iOS simulator. And so there's some assumptions that need to be kind of changed in Bazel for that. The Google folks are actually actively working on that. They're kind of pushing out some stuff related to that. I don't know what their specific timeline is, but I'm pretty optimistic about that stuff. But that's the biggest thing that kind of needs to be broken apart for that to work. There is some open source patch somewhere out there that kind of gives you like a hacky workaround for now, or just kind of renames one of the architectures or something if you really needed it. So far, we haven't like handed out any M1 machines to engineers at Lyft, so it hasn't been a huge problem for us. But and then the last piece I think for this is like XE framework support, which kind of, I don't remember what year that came out in Xcode, but that was kind of the required for this because they can't have fat binaries that have multiple architectures again for different platforms. Right. Mm-hmm. Yeah, so I don't know if any of the other rule sets have anything for that. Again, that's been one of the things since we haven't handed out M1 Max that we haven't had to deal with yet, but we'll definitely have to provide a rule for that soon. There is an issue for that on the Rules Apple to follow. I think the Google folks are interested in that one as well, but we'll see how that part plays out. I'm excited for, the next round of M1 machines where we start to see a little bit more power. I mean, even these initial set seems like it's still worth it, but I think people will get really excited about it once you have a 16-inch MacBook Pro or something, considering that the MacBook Air is already as fast as the previous Intel ones.
Right. Yeah. I like the idea that the maybe the M1s will be kind of a forcing function to get XC framework support implemented. That's great. Okay, and then maybe some thoughts on Swift modules, which I know is another issue that's been open for a while, that it doesn't seem like much support has really been landed there. And obviously that relates maybe a little bit to the explicit module stuff, but yeah, any thoughts there?
Yeah, I think the explicit module thing is kind of the biggest thing there. I think there's definitely some annoyances around the way that those work today, just like Swift modules in general. I mean, it could mean a lot of different things, but I think one of the annoying things that comes to mind is about like how your project recompiles depending on what you change and how that affects incremental compilation. So in general, the story is that even if you change internal functions and private function signatures, when you rebuild, you end up rebuilding everything up the transitive dependency tree because Swift modules are kind of inputs to everything up the tree. And that, of course, causes big incremental compilation issues. The exciting thing that's happening here is that the version of Xcode that went into beta like last week, which is 12.5, has Swift 5.4, which has a new feature for incremental compilation where it's actually smarter about not recompiling things that if nothing from the public interface changed, kind of up the tree. So definitely interested to see. I think that requires some rule changes because of, just some implementation details there, but I'm definitely interested to see how much that helps because I think that's a really big pain point for people with like large Swift code bases.
Mm-hmm. Yeah, that's definitely exciting. I don't know enough about that change in Swift. I mean, I'm always a little bit hesitant when I hear about incremental compilation coming from outside of Bazel, obviously, because it implies maybe some state somewhere. But it sounds like in this case, maybe it's just a little bit smarter. So do you know enough about the details there to know is that going to break hermeticity or anything like that?
Yeah, so it's an interesting topic with incremental compilation in general in Bazel, right? So Bazel wants to not have to do that, right? And it's very happy with the C compilation model where, it compiles one file, it just recompiles that, it's happy with that. But that doesn't work for a lot of languages, Swift and Rust definitely being two of them. It seems like, I don't know what the design decisions are behind the kind of compiler model where you give it an entire module's worth of source files and it's up to it to decide what to recompile. But that has not gone very well within Bazel. So Rule Swift actually supports a persistent worker in order to get around the fact that it's not hermetic. So it can actually kind of store this incremental state without Bazel really knowing about it and kind of push that around so that you can get incremental builds. So it actually already does that today. It's just that the change in Swift is expanding the scope of how smart incremental builds in Swift can be such that like today, the only incremental bit is how much do you need to recompile in your module. But then after that, you have to recompile everything that depends on it, theoretically. Whereas with this new feature in Swift, it's not only incremental in your module, but it's also incremental between module dependencies. So that definitely will require storing that same kind of state that you can store today if you enable incremental compilation in Swift with the rules, which is definitely a trade-off between performance and hermeticity. And I think that an interesting theme from us switching to Bazel is that there's a lot of this, and it's kind of something that you have to figure out how to balance.
Live with.
Yeah, exactly. And, the thing we were talking about the module cache earlier is another one where you could, be as hermetic as possible and have a separate module cache for every action. But if that adds 10-second compile time per module overhead, like you're not going to do it, right? So trying to balance that stuff has definitely been interesting.
Yeah, it's always the challenge. And then as far as some other hot topics in the rule set, so mixed source modules, I feel like we have to touch on it.
Yeah, it's an interesting one. So, I mean, I guess the background here is that, of course, this is just my impression, but as far as I can tell, kind of the way that this evolved was that Apple wanted to make it really easy for folks to adopt Swift. So they allowed you to add Swift and Objective-C to like the same target in Xcode and just treated that all as one thing, even though under the hood that meant doing multiple compilations in, very specific order and stuff. And that's like kind of against the way that Bazel architects rules. Rules are supposed to be kind of a smaller unit of measure or something, or targets as well. So having multiple languages in one target is definitely strange from the Bazel side of things. Although it's interesting because the Objective-C library is kind of a weird outlier to that, where it can have Objective-C and Objective-C++ in it, and it handles that pretty well. But yeah, so the original Apple rules and coming from Google didn't support that. I think mostly because, Google realized that that might be a pain and they didn't do it, which I think was the right decision. But now the problem is that a bunch of folks have done that in their Xcode builds. And so they're migrating to Bazel and they don't want to also try to figure out how to break apart their big mixed source modules at the same time, because that on its own can be a huge amount of work depending on how big it is. Luckily for us, since we only had Swift, we never had to deal with this problem because back in 2016 or something, we did a Swift rewrite. So that was great. So we kind of just ignored that. But yeah, a lot of folks today are hitting that. One of the external rule sets or outside of Rules Apple called Rules iOS has a rule for that. And the line one might as well. I'm not actually sure.
It does.
Okay, yeah, I think both of those are worth trying. I think I haven't spent much time with them since we don't have Objective-C and Swift, or Objective-C in general, but not mixed source modules as well. But, it seems like folks are using those successfully now. So that's probably the recommendation. I think at this point, given that it seems like there's consensus that no one really thinks it's a good idea going forward to have mixed source modules, it probably won't ever make its way into the official rule set. I mean, it's kind of an interesting, trade-off between pragmatism and, I don't know, cleanliness or something, where ideally no one has these, but of course everyone does. But it's just kind of an annoying problem you could look at the implementation of the rules, I guess, to see how you kind of have to mix the two things together to get it to work. So we'll have to see. It kind of depends a little bit, I think, on how the Objective-C rules evolve as well. Like those are still part of core Bazel where they're written in Java. And there's, hope in the future that those are extracted into Starlark, which I think in some ways would make it easier. But we'll have to see how that stuff evolves. But in the meantime, I think those external rule sets are the way to go for that.
Sure. And so let's touch briefly on the fact that most people, basically there's consensus that it's not a good idea. So that might be a surprise to some people. So what are the reasons that larger teams especially might not want to have mixed source modules?
So I did gloss over that. Sorry. I guess that the big thing that everyone has kind of seen with this is, especially if you have larger modules, you end up in a state where you have to have some bridging header, which is the way that you bridge between Objective-C, like Swift using your Objective-C. And the problem with that is that it very often leads to unnecessary recompiles because, maybe unnecessary is too strong of a word. Maybe it's just that the Swift compiler doesn't know what needs to be rebuilt. So a lot of folks find, especially in their large modules, that if they change any Objective-C, if it's transitively included from the bridging header, you kind of recompile the whole world, which takes a huge amount of time. So that's kind of the core issue. Like it's very specific to build performance and optimization before I think it's a real problem. But that's the thing that I've even heard from smaller teams about that being an issue. So that's kind of, I think, what's led everyone to this instead. I think there's also some weird gotchas around how stuff is imported, but maybe that's just normal Objective-C interop stuff. Luckily, again, Lyft has been able to kind of sidestep a lot of those problems.
Right. Yeah. That's always a problem. Yeah, definitely. I think the performance is the thing that we're most concerned with too. Like just the build times. I mean, they can be many times higher for the mixed source modules than an equivalent module in pure Swift or something like that. So it's pure Objective-C even. So that's definitely concerning. I've heard, I forget who it was. I've heard someone in the community mention, like, even if you do start mixed source modules, like once you look at where your time goes during the build, you're going to refactor them anyways, just to remove the mixed source dependency. So great. Yeah. And so another item in the rule set that had maybe a little bit less support in the past was code coverage. And I know that's something that I think you've been working on even recently, right? So how's that looking these days?
Yeah. So code coverage with Bazel in general, I'm not really sure what the state of that is. Like, I think there's been varying amount of effort from the Google side of how that's supposed to work. But yeah, we have it working at Lyft. Again, given that we don't have any Objective-C, like we're kind of maybe sidestepping some potential problems that folks would hit otherwise. All the infrastructure is generally there in Bazel. It's just a matter of how you kind of wire it up. The big thing that's missing in the open source rule set is support for it in the test runner, where the difference generally is that like you do a test or you do a test with coverage and they change some environment variables so you know what you're doing, and then you're expected to output some specific files in certain places with the coverage data. And the open source test runner just doesn't do that. But I think that that's a good starter task for someone who's kind of interested in that. There's an issue about it with some kind of pointers on what you need to do, where I think I copy pasted some code snippets from our internal test runner for that. We have this internal test runner for like totally unrelated reasons. It just so happened that it was kind of easier for us to implement code coverage there than it was to switch back to the external test runner and then try to implement it. So yeah, that was a different problem. But I actually think that if you're really interested in that, it's not too bad to hook up those pieces, and then you can get whatever kind of format you want out to send to whoever other code coverage service you're using, or to just show that in HTML. Like you can generate HTML from those reports too, which we do as well. That can be kind of useful.
Gotcha. Yeah. The state of code coverage in Bazel in general is definitely a tricky spot, because I think that what Google does internally with Blaze, they have like a whole separate system. And then the thing that we've got in Bazel is kind of just a separate thing that someone either contributed or someone just gave to the community. And it's sometimes there's some challenges there, especially we've seen issues even using build without the bytes and trying to run coverage repeatedly with build without the bytes. There's some issues there, because it just, we don't need to go too deep in the weeds there. But yeah, definitely a topic that I think in the coming months, I expect to see a lot more improvements there, hopefully. Okay, cool. And then maybe just in the context of this rule set, I'm interested to hear if there's any, I mean, I think you might have touched on it, like just some changes coming to static and dynamic framework implementation. And so maybe we can give a little bit of background. So most folks who work in iOS are going to know, about dynamic frameworks. People from outside of the community, maybe not so much. And I think another layer of complication is that the way that these things are used in the context of rules Apple are a little bit different maybe than an iOS developer's expectations might be. So maybe that's something worth breaking down for folks.
Yeah, so definitely a few different pieces there. One is like, why would you want one over the other? And then the other is, what's the support in Bazel? So on why you might want one over the other, I guess historically there have been a few different problems. One is app launch time in the past. I'm not sure if this is true today. Supposedly it's not, with improvements in the dynamic linker from the Apple side. But in the past, having more dynamic libraries meant more overhead right when you launch your app for the dynamic linker to discover the things that you depended on. I don't think it's worth trying to dive too much deeper than that, but the TLDR was like it could impact your launch time. And so a lot of folks went to static linking instead because of that. But that has the adverse effect potentially that if you have a lot of app extensions, you end up with some duplicated code in your final app that you ship, and which affects download size. So there's some kind of trade-offs there depending on your situation. We don't have many like extensions or anything, so we're not really worried about that case. But from Google's side, they were kind of in the boat of always static link everything. I think that probably didn't come first from iOS. Like I assume that had more to do with the C++ side of things there. Although C++ does have some support for dynamic linking in Bazel, but yeah, so that wasn't really a goal as far as I can tell of the original rules. So really the context of the Bazel rules, there was some support for dynamic frameworks, like as far back as I can remember. But it was kind of strange, maybe from the Xcode side, where you kind of think of a library as being either static or dynamic. In Bazel, those two things are separated. So you have a library, and then it's either like it's static by default, but then you can kind of attach this dynamic thing to it in the form of another target, which is a kind of a strange thing to juggle. But in general, you can probably make that work, although maybe it requires a little bit more work in your custom macros or something. The problem that we hit at Lyft was actually just that we had too many libraries. And so that ended up not working to the point where the app would link fine, but then it would crash at runtime. That's something that the Apple folks actually like bumped the number on how big that kind of thing can be. I'm not sure if it's backported. I don't think it is. So I think that you'd have to like deploy to minimum iOS 14 for that to actually work. But for local development, that could be okay for us because it's probably worth it. But yeah, there's a little bit of difficulty there. There's also some other kind of dynamic binary related things happening in the rules that's kind of interesting. So one is recently some folks landed support for like vendoring dynamic frameworks, which can be useful depending on how you want to transition to Bazel. A lot of folks have taken the path of like build one or two libraries and then pull them into their Xcode build, but they're built with Bazel. And if you want to do that and produce dynamic frameworks, there's a rule for that now. And then the other thing is Swift UI previews. Like if you're interested in getting that working for local development, but building it with Bazel, there's you can probably do it with the existing rules. And actually we are at the moment as well, but there's also a rule open for producing like a dylib that you could theoretically take and give to Swift UI previews to make that work inside Xcode. So there's a few different like threads there, but in general, I think a lot of the kind of core issues are being resolved. So it's looking pretty good.
Cool. So I think maybe just to touch on it. So folks that have a lot of existing static frameworks, that doesn't really map to the idea of a static framework and rules Apple. It maps more to just like a library, which is going to be a static library, right? So maybe is it worth talking a little bit about like what the iOS static framework rule is used for and rules Apple?
Yeah, we've been talking about static versus dynamic, but then there's also library versus framework, which is kind of a different dimension, but often people, I think, get them confused because they're used to seeing one or the other. They're used to seeing static libraries and they're used to seeing dynamic frameworks, but theoretically, like you can have static frameworks or dynamic libraries, like all kind of that's just a matrix of options. But on the framework versus library side, it's more just about packaging and like what flags you need to pass to the compiler or the linker to discover the libraries or frameworks that you're linking against, and then how you include resources. Either of those kind of work either way. There's some trade-offs, but you can kind of make either one work. Yeah, so the iOS static framework rule is one from Google that I think has existed for a long time, where they ship their kind of third-party frameworks like Google Maps as static frameworks to folks. I assume they chose static frameworks as opposed to dynamic frameworks for launch time concerns or code stripping, which you can't do with dynamic frameworks or something like that. But you can use that only to vendor things. So it's kind of an interesting one where, yeah, you see that, you may think, oh, if I have frameworks now, maybe that's the right rule to use, but that's really only meant for like vendoring a framework for someone else to include in their project. And then it's kind of expected that you'd instead just use a static library. And then if you have resources that you need to deal with, use a separate resource bundle or something like that.
Mm-hmm. Cool. Moving onward a little bit, in the context of rules Apple and rules Swift, which are the things that you deal with, what are some major unsolved issues still for the community that are worth touching on? So I've got a list here that we can definitely run through. From my point of view, there's definitely some issues. I'm sure there's a couple of things that you're aware of that I haven't even thought about. So I want to touch a little bit on that because I think that's, as more and more folks start to onboard, of course, to building with iOS, these are things that are bound to come up. And these are some of the things that are probably keeping people from making the leap even so far. So yeah, we can touch early on whatever you want. Obviously on my list here, some of the things I think that are pretty serious are, so the sandboxing, which we touched on briefly earlier with the Clang module cache and the Swift module cache. So maybe that's something to talk a little bit more in detail about, if you have any thoughts there.
Yeah, like you said, I feel like we've mentioned that a few times, but kind of similar problem to remote execution with sandboxing, you'll lose your implicit module cache between compilations. So you'll end up being hit for that like every single time you compile a new thing, and that can end up adding a ton of time. I think that the way out there is the explicit module support that we talked about. And it'll be interesting, what the actual impact of sandboxing is, because I think sandboxing, especially on macOS, has gotten a really bad reputation in Bazel for performance. But I think most of that is actually probably due to the module cache issues more so than just the overhead of sandboxing itself. But I guess that's to be seen once we figure out that issue.
Yeah, definitely. So again, a little bit more background. Like if you were to run a Swift compile with sandboxing enabled, what kind of speeds would you expect there versus running it without sandboxing?
Yeah, so I mean, the module cache bit, it's a matter of how many system frameworks, I guess, that you import, like maybe transitively. So the more you import, the worse the hit's going to be. But I think that there's like definitely some constant time there that's pretty serious. I don't know if I have a up-to-date number off the top of my head, but I'd say like, I don't know, probably anywhere between 10 and 30 seconds or something just for that. And then that gets totally discarded. And where ideally like the Swift expectation is that that only happens once. And then maybe you add to it as you compile new stuff that imports new stuff, but you never have to rebuild it. So you kind of get that like static overhead of, or constant overhead of 10 to 30 seconds or something. Yeah. Besides that, like I said, it's kind of hard to say like how much worse off the compile is otherwise, because I feel like that's the bulk of the issue.
Right. Yeah, definitely. I agree there that the caching is really making it just hard to tell what the overhead would be otherwise. So yeah, I think a number that I have seen thrown out in a couple of real world projects, I think more heavy on the Objective-C and mixed sources, but a number I saw was about 20 to 25x slower to compile with the sandboxing turned on. So it's just not an option. And so you can imagine, I mean, if just running locally with sandboxing is 25x slower, like you have that much more of a hill to climb to get any sort of a gain out of your remote execution. And so I think that's the blocker right now for a lot of folks that are looking at running these builds remotely, like just impossible without some sort of a unique solution to handling that caching or, eventually, explicit modules.
Yeah, for sure. For remote execution, that seems like a huge problem. We're going to have to see what we'll try to do about that too. But yeah, on the local side, for local development and for like PR builds, just to keep stuff super fast for us, we disable sandboxing. I'm not super worried about it either, especially because we don't have many folks kind of writing rules themselves. So I think we would mostly notice if something actually non-hermetic made it in. But we do build release builds with the sandbox just to be extra careful. And because, we don't really block on those anywhere. So it doesn't really matter if it takes a lot longer for us.
Yeah. And how much longer do those take?
Well, it's hard to say like for fair metrics because we also build those with full optimizations and we don't build the other builds with optimizations. But I mean, it's definitely at least 5x or something. I'm not sure.
Cool. So yeah, I think we've touched on a lot of this stuff. So in the context of remote builds and some of the other unsolved issues, I know there's always a lot of talk about, especially with folks doing anything with mixed sources, there's the issues with the header maps and the paths. There's a lot of like absolute and host specific paths that don't really work across machines. And that's something that we've been hoping gets resolved in the rule sets. And then, of course, just remotely built Swift is, of course, really hard to debug locally because of the paths issue. So is there any ongoing work or effort there?
Yeah, so absolute paths are all over the iOS toolchain historically, but I think a lot of the issues have been resolved. Again, just another disclaimer about how we only have Swift, because I think that helps us in this case. But there's a debug prefix map flag to the Swift compiler that allows you to like specify the path to rewrite from absolute to local, and then you can later remap that in the debugger to try to fix that problem. And as far as I know at this point, maybe it requires Swift 5.4, but you don't end up with any like host specific paths in Swift. I also added a coverage prefix map to the Swift compiler as well for the same problem, but for code coverage data, which also had separate absolute paths. So there's a few different like bits you have to flip there. The rules support them, so you can just like enable those features. We don't enable them by default because it would break debugging immediately for people. Like if your first attempt locally only built wouldn't work without doing some debugger configuration, which is too bad. But it's pretty easy to do the debugger configuration. And then, Xcode as of, I don't know, just the past 2 years or something, supports like checking in an LDB init file somewhere in your project. So you can do that without developers even having to do anything locally to configure their LDB config. And so Tulsi does that as well. So that's much nicer than it used to be. And there is a way that kind of you can fit all of those pieces together to get remotely built debuggable Swift. There's a document about how to do it kind of floating around in this repo called iOS Bazel users that you can probably Google and find. But you kind of have to do a little bit of juggling where you flip on some switches in some places and off in others. But that's been working really well for us. I think that we've been having that working for the past, I guess, few years. So I think that all of the issues there are unblocked at this point. But I guess the last piece that was fixed recently in Bazel was having support for relative paths for linking with Swift modules, where the way that this works is when you link your kind of final binary, previously you had to pass the absolute path to every Swift module from your build so that the debugger could say like, okay, I understand these types. But it turns out that I don't think that was ever a requirement, as long as your debugger's like PWD was set in a way that it could discover these files. So doing that, you can make those paths remote as well, which means theoretically we could allow linking to happen remotely as well. I'm not sure how realistically helpful that is, considering the fact that you'd have to end up downloading that final binary anyways. And again, going back to network performance, maybe that's not worth it, but at least all of those pieces are there. So you can kind of try either route and see which one actually works best in practice.
Sure. Yeah, I guess having Dave working on LLDB must be nice because you can kind of collaborate getting some stuff escalated, huh?
No comment.
Cool. Okay, so moving on, but also somewhat related. So precompiled headers, I know that this is something that you've been working on recently in the context of more of a C++ project, but I think that's something that's really interesting to folks doing stuff even with mobile. So you want to talk a little bit about that?
Yeah, so on the Clang C++ Objective-C side of things, one thing that I think a lot of folks have used in the iOS community for a long time is precompiled headers, where they define some, probably just system libraries. The headers get set up once and then you're good to go. People might have just abused that for also not having to import stuff, but which is also, I guess, another nice benefit, but it has a potential like build performance win. So the Envoy project, which is a service proxy, folks may have heard of it, very big C++ project, very early adopter of Bazel. I think the Google folks really helped a lot with that, which really helped the Bazel community because I think they found a lot of issues, and there were Google folks directly helping kind of integrate it and everything. So it's been on Bazel for a few years, and very large C++ project, tons of different targets, tons of different test targets, lots of stuff, lots of headers getting reprocessed for like every action. So one of the things that they were kind of hoping to do was do a proof of concept of precompiled headers where we could not parse these headers so often. I think that there's a few different areas where they were specifically like sensitive to that, especially when it came to testing, where they had a bunch of mock targets that, I guess I'm talking a little bit out of my depth here because I'm not working on Envoy full time, but it seems like the case was that these targets weren't really ever changing, but they have huge headers and they're getting reparsed for like every test. So they were wondering if they could integrate precompiled headers for that. And I think some of this is like a precursor to C++ module support in the future with Bazel, which is, I think, a highly requested feature from the C++ side. And there's some open issues about it on Bazel and some folks working on it. But the hope was that we could do some precompiled header testing so that we could kind of understand what the ceiling of performance benefit was, or the floor of compile times, or whichever way you want to look at it. So I kind of helped out a little bit there just to kind of write a rule for that, since I'm pretty familiar with Bazel at this point. And there's a PR open on Envoy that you can see. Hopefully it gets merged soon if that's the path they decide to do. But I think that the overall TLDR was that, for incremental builds, you get a potentially like 25% compile time win, which is really nice. And I think that you could probably even tweak that further depending on what targets you can kind of put in the precompiled header. It's kind of a balance between how often do you invalidate the precompiled header and depending on what you're changing and stuff. So it's kind of up to them to figure out what targets are the right ones to fit in there. But we threw a bunch of them in there that we felt like were common ones. Like, for example, they use the Google test framework for C++. They're not changing that very often. So that's a perfect one to be in there because it's included by every single test file. So it wasn't a crazy rule to get working. I think if folks are interested in that, they could probably pretty easily adapt it for other projects. I think the reluctance from the Bazel team on that side is probably more around the fact that those precompiled headers, like implementation detail wise, are like apparently a dump of Clang's memory at the time it loads the headers or something. So it's very non-hermetic. Like it's totally, I don't know enough about C++ memory layout, thankfully, but I'm pretty sure that if you like added a field to some struct that related to this in the compiler, like it would be invalid now. So it's kind of a weird thing. Because of that, you end up having to disable sandboxing, and then Clang, fails based on timestamps and stuff. So it's definitely another one of those trade-offs between hermeticity and build performance that you have to figure out whether or not it's worth it. I think probably for 25% build performance, it is worth it, but I'm kind of hoping that that can all go up in flames and we can add support for C++ modules instead, which I think would be much better in the long term.
Sure. Well, it's cool. Yeah, I think that's a great, an easy 25% plus, for big C++ projects. I think there's definitely some folks that would be interested in that. So it's very cool. And so in the context of the rule sets, I guess I kind of jumped out of the context of rules Apple briefly there. But I guess one other thing, so obviously third-party dependencies are something that every iOS app has. And I don't know, there's not really a great mechanism in rules Apple, rules iOS to handle this yet, is there? Rules Apple, rules Swift. So is this just another case of like depending on a third-party rule set to get this done? Or are there any plans to have native support for this in the rules Apple? Or what are your thoughts there?
Yeah, it's definitely an interesting area. So I think there's a lot of different things to talk about. One of them is, how many third parties do you rely on? And that whole conversation about when is the right time to use third parties. Like I think unlike some communities, everyone kind of digs in the JavaScript community for this, but the iOS community I think is pretty conservative about using third parties. Like I think a lot of especially bigger iOS apps try to reduce their number of third parties. I know that we have for a long time, and I think that has mostly been the right decision for us. Obviously, there's a lot of trade-offs there, and there's a lot of talks from the iOS community about when you should use third-party dependencies versus writing yourself. So if folks are interested in that, I'm sure they can find some other thoughts on that. But we've generally tried to avoid that for a long time. So this wasn't a big piece of our Bazel migration. So we actually took the path of handwriting build files for our few third-party dependencies. But amusingly, we were actually doing that before Bazel. We were handwriting them and then building them with Swift Package Manager in kind of an interesting way, with just kind of an internal tool that I wrote to just do the right, kind of compiler invocations for that. It was pretty nice because we could get away from having any major dependency on a package manager and having developers have to build as part of the build. So we pre-compiled these things and then we just had developers download them from S3 or whatever. And that kind of led to us being much more flexible. We actually continued using that scheme after we migrated to Bazel, and then we just migrated those later because either way that was compatible with Bazel as well. So depending on the number of third parties, I think that's definitely a viable approach. One thing I would like to see from the Bazel community in general is more around people sharing build files for that kind of use case. Like I think a lot of projects, especially with Swift PM kind of encouraging it these days, I think a lot of iOS libraries are very simple to build where, they have one directory of sources and really it's just, you just glob that and you pass them all to the compiler and that's the whole thing. So I think there's definitely an opportunity for a kind of third-party repo somewhere of shared build definitions for popular third-party libraries. I think we'd be happy to share a lot of ours there too. I guess the only downside is if you have kind of some internal syntax sugar or something like that on top of the libraries, maybe you lose something there. But I don't think that's a huge problem. So I think that that could really kind of push this forward. And I actually think it could open up a new kind of use case for Bazel where folks could use Bazel just for that if they wanted to. And then they could vendor those kind of pre-built libraries and then include those with Xcode, which if you're using CocoaPods, the way that that works, developers could end up rebuilding all the third parties, even if they didn't change them. Not the fault particularly of CocoaPods, but if you do it clean, that's just the reality. So that was a huge build time benefit for us.
Yeah. Yeah.
Yeah. I was just going to say that, the other path, I guess, in the kind of third party, what do you want to do is you can definitely go down the path of using something like Pod to Build, which I think is on the Pinterest GitHub org, where, you try to kind of bridge CocoaPods to Bazel in a more generic way. I've never personally tried that project, but I think that they're using it to some success. So I think there's definitely some options there. But it'll be interesting to see, I guess, kind of how Swift PM evolves. There was an attempt at some point in someone writing a Swift PM kind of Bazel rule that I think theoretically we could get to work. I haven't really looked at it. I think the PR is actually still open. It's a few years old at this point, from before we started maintaining the rules. But I think there's a possibility we could get that working as well if folks in the iOS community kind of move further towards that now that there's better support for some iOS features in that, like resources and other things.
Yeah, definitely. I think Swift PM, it could be huge. Yeah, it's been, of course, sad to see that it hasn't really had much adoption, definitely in the Bazel side of things yet. But yeah, I think there's a lot of promise there. Yeah, so, okay, we've touched a lot on the existence of third-party rules. And, I guess maybe we want to take some time to dive a little bit deeper into just some of the other third-party rule sets that are out there that build on top of Rules Apple and Rules Swift. So obviously, Rules iOS is a big one. And so, I know that you don't work on this, but I feel like it's something that we should at least discuss for the benefit of the listeners, just to kind of give a good lay of the land here. So, so we've talked a lot about these third-party rule sets. Maybe let's expand on that a little bit.
Yeah, so I guess it seems like in the iOS community right now, there's like the two big ones, both that we mentioned, the Rules iOS and then the Apple Rules line on the line GitHub org. I think both of those have some really useful rules for folks, especially, we talked about the mixed source libraries. I think that's a big one. I think that the Rules iOS repo also has a header map rule, which I think is useful for folks who have a whole bunch of Objective-C and have spend a bunch of time with the compiler searching header search paths for things. So I think there's definitely some useful stuff there, and folks should definitely check them out if those are the problems they face. I think there's kind of an underlying question of, what makes sense to be official and not. And I think that there's a lot of question marks there from my side too. I mean, I don't think that there's any reason that things from those couldn't be merged into the whatever main repos, whatever you want to call it, as long as they're generally applicable. But we haven't really made an effort to do that at this point. I guess it's so easy to pull in another rule set and just use another rule that I guess no one's really been super motivated to try to do that. But I think that there's definitely potential for that in some places. And then I think on the other hand, some of the rules might be, more specific and less general, in which case maybe we don't want to merge them into those. But if you can make it work for your project, that's still totally fine. I think we have a lot of internal stuff at Lyft where it's kind of a similar thing. It could be generally applicable, but right now it's something that's, super specific. We have a lot of examples, I think, of that are just, we can make it work for only us, and that's great. And then, it's a different kind of question whether or not you want to open source them or whatever. I feel like it's a similar kind of conversation.
Sure. And so I think one element that Rules iOS, the third-party rule set, does offer at least some sort of a solution to, kind of alternative to what you might do with Rules Apple, is project generation, which is something that, we touched briefly on that, what it looked like in your journey. But project generation is definitely an area where the community has definitely had some struggles. And really just Xcode integration in general. So obviously a lot of folks, working with Bazel in the community right now, they're using VS Code and they're using the IDEA plugin. There's a lot of decent support there. Of course, for folks in iOS, we're stuck with Xcode. And so integrating Bazel and Xcode can be a challenge. And so broadly speaking, obviously this is broken down into kind of two major areas. There's the project generation side of things, and then there's, of course, the indexing of the source code to get the other IDE features that you want. And then lastly, kind of the integration with the test runner and the various UI controls and things like that. So project generation under Rules Apple is kind of the official support is for Tulsi, which is kind of something that a lot of folks don't really get a whole lot of mileage out of. And so there's some alternate solutions in Rules iOS. Does that seem like something that might make sense to look at moving into the official rule set?
Yeah, I think that there should definitely be some official version of that that most people can use and definitely folks can start out on. Like super specifically, I don't think it particularly makes sense in Rules Apple, but I think it makes sense on like the Bazel GitHub org. But yeah, I do wish there was a bit better support there. I think that the problem that kind of everyone has faced is that, Tulsi is a generalist tool. It does a lot of stuff. It solves, I guess, must solve every use case within Google, which I assume is pretty wide. And so it's definitely worth trying out to see how well it works for your case. I think in our case, we wanted different UX, and we also wanted to kind of do some stuff that kind of broke the model of what Tulsi was doing. Specifically, we were really interested in doing what we call focus projects. I think a lot of people call it this, but where instead of generating an Xcode project that has like every single target that you're going to build, if you hit build, we generate one with only the targets you care about, which is just useful for trying to understand what you're working on, what files you can look at without seeing a bunch of unrelated stuff. Also, Xcode can get really sluggish if you have a whole bunch of targets, so reducing that is pretty valuable. So we didn't really feel like we could kind of shoehorn that stuff into Tulsi very well, which is why we decided to kind of do our own thing. And I think a lot of other companies kind of went down that same path for similar reasons. And so I think what this has led to is pretty much like every company has their own solution for this internally, and it works well for them, and that's okay. But yeah, I'm really hoping that, we can figure out or find a good reason for us to all kind of collaborate on something instead. The benefit of the way that can work for us internally is just that we, again, have to support many fewer use cases where, all of our sources in one directory that, lets you remove a lot of assumptions. Like we don't allow people to do things like you only depend on a library for device, but not for simulator or something like that, where in Tulsi's case, you have to generate a project knowing which you want to build for up front or something like that. So, it gives us a lot of nice leeway to simplify. But yeah, I think that, that's kind of feels like the biggest overhead to trying out Bazel seriously today is how do you make it work at all in the IDE? And all the tools are out there for you to build your own thing, but it's, obviously a big effort.
Yeah. And so in the indexing front, also, there's a couple of different approaches there. Maybe we could talk just a little bit more about, and you have a great talk on this, so we should definitely just steer folks that way as well. But talk a little bit about how the indexing implementation, at least at Lyft, went and kind of what people can expect there when they start looking into that.
Yeah. So the talk you're referring to is from, I think, 2019 BazelCon. My colleague at the time, Dave Lee, and I did a talk just about the migration. I think we covered a lot of similar stuff today, but yeah, he went really into depth about how our project generation bit worked. And yeah, the big discovery from him there was just about like how we can take the indexes that the compiler actually produces, just like they do when you're using like vanilla Xcode, but taking them from Bazel and making Xcode like be happy with them. So part of that was he open sourced a tool called Index Import. It has a dash, I think, between the two words that you can find on GitHub that lets you kind of rewrite some of the paths to what Xcode expects, because that's really the only issue and the only difference between producing them with Bazel versus producing them with Xcode is that, it has some reliance on absolute paths for how to find the source files and stuff that are related. But, it mostly turns out that if you just give that to Xcode, it will happily do code completion and jump to definition and all the other kind of IDE features you'd expect. So that was a huge win for us. So yeah, the build process, like mostly, we run Bazel and then we copy that stuff over and a few other things that Xcode expects as well. And then you can pretty much get full IDE feature support from that.
Yeah, that's great. And then I've seen some talk recently about global indexes. There might be some wins there, but there's also some challenges. Is that worth diving into at all?
I think that's pretty similar to the thread on the explicit module stuff. I think it's kind of it would solve the same problem. So I'm not sure if that would actually help for remote execution. I'd have to look at those issues, but I think it's a similar vein.
Okay. And then this is somewhat of a tangent, but there's some work in various other parts of the development community to share indexes in a way. For example, like for IDEA, there's like actually like an index server and you can share, because, with people working huge monorepos, these indexes can take quite a while, especially the way IDEA builds them. And so what are your thoughts on like shared indexes for, an iOS project? And like, a lot of this stuff, like obviously it's based on the output of Bazel, so hopefully a lot of it can be cached. So is this something that we're kind of getting an implicit shared index kind of by default because we're going to be pulling these things down from the remote, or are these indexes not easily shareable? Or any thoughts there?
Yeah, so the Swift rules have a feature that you can enable to produce the index stores, and then those do get cached. So that's what we're using, and that part works great. at the end of the day, we still end up using that index import tool, which replaces some paths, but they have to end up being absolute anyways. So I think we're sharing them as best we can today, because you still have to end up rewriting them to whatever the user's specific checkout location kind of path is. So that works pretty well. The native rules with Bazel do not have that same functionality for Objective-C. So I don't know what folks are doing there. I don't know if there's a way you could get that to work with some other kind of Bazel feature. Not really sure. But I think theoretically that could be solved as well. I mean, I think there'd probably be some implementation concerns, but you could probably figure that part out. So I think that the caching bit there is definitely in the right direction. I think that with explicit module builds plus that, I think you'll have everything you really need for that kind of thing, which will definitely help with remote execution and stuff too.
Mm-hmm. And what about the indexing while building? And then even also kind of related to that is there's obviously that's kind of just, I think, a compiler flag or an Xcode flag. So I think that's kind of one topic. But then another semi-related one is just, it's also true that the output of Swift-C more or less like the Swift-C auto indexing, like that's already kind of sufficient for some use cases, right? So I guess what are your thoughts on the kind of the automatic Swift-C indexing that's happening like through Xcode all the time? Like, is that not sufficient, or how does that interact, I guess, with index import in your case?
Yeah, so index while building is the same thing that Bazel is using. That kind of Xcode setting translates to, when you do your build, pass the right flags to produce an index store. But then, right, like you said, Xcode in the background is also doing indexing. So the problem with that in our case is that Xcode doesn't have a full picture of the build. So that indexing will never succeed that's happening in the background, because it'll try to do a build. But since we don't give it all information about all targets in the dependency tree, that just immediately fails. So that's why we have to kind of do this index import bit. Theoretically, if you didn't do the kind of focused projects thing that we did and you included everything, it could work. But I think that that'll generally like limit your ability to use all of Bazel's features, because at some point you're going to get to a point where you want to do something in Bazel that isn't easily translated to Xcode, and then you're going to have to figure out how to bridge that. And in this case, we don't really have to do that, because we just kind of, trust whatever Bazel gives us and give that over to Xcode instead. So, there is the UX downside there where you don't get continuous indexing, at least not in all cases. So, I think you could solve that if you really wanted to with some kind of like local daemon that just kind of ran Bazel in the background or something if folks didn't build in a few minutes or something like that. We haven't gotten to that point. I think that most people are okay with updating the index when they build. I think that that's often like building is part of their iteration cycle anyway. So it's not like they go a huge amount of time changing code without having ever built. So I think that's working pretty well today. But we've talked about going down the kind of daemon route to make it feel a little bit more like Xcode, where it updates more immediately.
Yeah, it definitely makes sense. So the background, like the automatic indexing, could never work, obviously, if you're just looking at a scoped version of your project, of course, because you're gonna be missing dependency definitions. Gotcha. And then you kind of touched on like some more advanced background daemon, things like that. I've heard some talk in the community about integration with like XC build service. And I'm not sure exactly if you've looked into that at all in the context of the current rules. Anything to expand on there?
Yeah, there's a few open source repos for that. One is on the Target GitHub. I don't remember what the repo's called, and I think the other one's called like XC Build Service or something like that. The gist of them is that they kind of take the place of Xcode's newer build system that runs as kind of this separate daemon thing and communicates back and forth with Xcode with like message pack or something. So people kind of reverse engineer that protocol and put their own kind of program in between those two things. It opens some interesting doors where you can more accurately make Xcode reflect the build. So one of the problems that people have talked about a lot in the iOS integration is like, if you integrate your build as just a build script in Xcode, so it's just kind of running a shell script, Xcode doesn't know how to show progress for that. So it just shows 50% progress and then that's it. Like, so, people don't really get a good sense. I would argue that progress bar isn't super useful in the first place because it's just like target based or something. So it really doesn't have much to do with exactly how long. I mean, it's a better approximation than just sitting at 50% the whole time. But so by kind of hacking into the back door of Xcode here, you can kind of get more Xcode-like features like that. We never went down that path just because we felt like we could get enough of the features that we were worried about without doing that, and that feels a lot more fragile. But I think that people have had some definite success with that, and especially folks who really wanted to get the progress bar working. And then there's also, I think that opened the door for getting Swift UI previews working in a nice way and stuff like that. We were able to get those working without doing that still, but We might eventually go down that path too, because it can open some other interesting doors. But, anytime when you kind of replace the internals of Xcode with your own dilibs and stuff, you're opening yourself up to more likely breakages as you update Xcode and stuff like that over time, which is why we've generally steered clear.
Yeah, it sounds really sketchy, the integration paths there. So I guess the takeaway here is that Lyft does not have a progress bar in their iOS builds.
No, they don't. Yeah, it's kind of an interesting one where we hear from a lot of companies that people really want it. And I'm not sure if folks are just used to it now at Lyft, but I don't really hear about it as much. But, some people swear that when they implemented the progress bar bit, people said the builds were faster. So, there's an interesting perception thing there.
Yeah, that's hilarious. Do you have any other way for developers to see like what's going on under the hood, or see like the Bazel UI, as they call it, being the console output?
Right now, it's just that you can look in the logs part of Xcode and you'll see it there. Yeah, I'm not sure. We've talked about kind of doing some other options. I know some folks provide like a Mac app that maybe streams the kind of build event log that can give you some more useful info, or some of the SaaS offerings have UI for that too, that you could watch that live. We're not using any of those right now, but I think that those ideas are kind of interesting, and we might do something like that in the future.
Gotcha. So we've talked a lot about, or at least reference the idea of like what folks starting out with Bazel might think of, some of the recent changes and things like that. But I think it'd be good to take some time to focus specifically on really the state of Bazel and for iOS in 2021, and what people starting out with Bazel can expect. I mean, just really any advice you might have, what might go differently for them versus how it went for you, or for obviously for Pinterest, who really blazed the trail here. So I don't really have a ton of like specific questions, but I guess there's a lot of variables here. And so, I guess what advice would you give to someone kicking off a project 2021?
Yeah, it's a medium-sized company or something. And it's like, we definitely get that they should basically migrate to Swift first or something. But what else do you have?
Yeah. I mean, I think definitely on the positive side, a lot of work over the past few years has gone into the rules and like making it work for more folks outside of Google, which I think means that the onboarding path is just getting easier, which is really great. I mean, obviously there's a big conversation around when is the right time to even consider this, because I think that there's a lot of things you can do to improve developer experience, or try to improve some of this stuff before you go to Bazel. I think some of them we kind of like touched on earlier, but I think that for our team, like moving to pre-compiled dependencies was a huge developer productivity win, and then moving to generated projects and stuff like that. So I think there's a lot of like incremental steps you can take, because Bazel is a really big hammer, right? It's a big learning curve of a tool. I mean, I think it's a really great tool, but if you don't have any background in build systems or Bazel, or you don't have anyone you can talk to who has that expertise, that can definitely be intimidating. So that's a big learning curve piece. I would definitely say that it's worth trying to get as far along as you can on a lot of those other things first, which will also make it probably easier to switch to Bazel when you decide that that's the right thing to do. But yeah, I'm super optimistic about the community in general at this point. Like, I think it's really great to see Bazel not only being adopted by a ton of folks in the iOS community, but in so many other communities. Like at the time that we were adopting it, we were optimistic about it, obviously, but it definitely didn't have the reach that it has today, where it's now more and more common to see Bazel-based projects out there. I mean, I think it really helped that Google pushed a lot of this stuff in a lot of areas. So a lot of their projects were building with Bazel and stuff like that, and stuff like Envoy as well. So I'm super optimistic about the future. I still think that you don't have many options as a super large, iOS company if you really need to solve some of these problems. So that's kind of what drove us to Bazel. And I think that will continue driving people to Bazel for a long time. We can talk about whether or not we think Apple will solve some of the specific problems, but I think it's fair that doesn't particularly have to be their focus. So I think that, this gives you a lot of flexibility, but the trade-off is you're taking on a lot of the responsibility, right? Like we've had full-time people, more than one, working on this practically full-time for a really long time, but we can afford that because we think it's worth it for the developer productivity wins. But you really have to be willing to make that, trade-off at your company, which won't always make sense.
Yeah. I think, we kind of recommend that too. Like, probably folks should assume that they're going to have they should have a DevX-ish sort of team, and they should probably have someone with iOS experience as well, just kind of around to make sure, all use cases are covered. For sure. And so another topic I think that we should talk a little bit about, the Mobile Native Foundation. So this is something you've been working on recently. So why don't you give us a lowdown there?
Yeah, so we're about to launch, as we record this, the Mobile Native Foundation, which is a Linux Foundation kind of sub foundation that's specifically focused on kind of the mobile infrastructure space. So not only build stuff, but also architecture and networking and design systems and stuff like that. And the goal is to provide a place in the community where companies can work on open source projects and have discussions and stuff that right now may not be happening. Like, I think a great example of this is the project generation bit on the build side, where, I think if we really sat down across a few companies who really wanted this and talked about our needs, like, we could come up with a real solution. And I think this foundation will hopefully be a great place to do that. But also just discussions right now where, I talk to tons of people from tons of different companies about Bazel or lots of different mobile infrastructure topics that I think has a lot of useful conversation that I would prefer be happening somewhere in the open. And I'm hoping this can be a place for that to happen, where right now it probably happens over Slack or, whatever, or meetings where, only some people are going to be there. So I'm really hoping that this foundation can provide like a nice discussion forum for that kind of stuff as well. So yeah, I mean, that's the kind of the pitch. If folks are interested, they can go to mobilenativefoundation.org, which has the links to kind of all of the specific stuff there. But yeah, hopefully that will be launched by the time this comes out. And then, we hope to see folks there contributing.
Great. Sounds exciting. Yeah, I think the Mobile Native Foundation is something that I didn't know that I wanted. But obviously, we've been talking, just even in the context just purely of Bazel, which the MNF goes way beyond that. But in the context only of Bazel, like, we've seen, unfortunately seen folks kind of re-implement a lot of the same functionality internally because it wasn't really available externally. And then there's been a lot of fragmentation, even though we're all kind of doing a lot of the same things. And so I think the Mobile Native Foundation is a kind of a great solution for some of that, because we can start maybe collaborating and sharing a bit more of that, and maybe even talking a bit early on before we build all this stuff from scratch, and find a way to kind of collaborate and building something, whether it's in the context of Bazel or of course beyond that. So yeah, it's exciting, and yeah, we're looking forward to that. And we'll put the link in the show notes here, which is something we're going to start publishing. Cool. And so I had a couple other just kind of random thoughts while we were talking. So Envoy on iOS. I know that the reason that you touched Envoy is because you're using it on iOS. Like, what exactly, why are you building it for iOS? What's the point there?
Yeah. So yeah, disclaimer, I'm definitely not the best person to pitch the whole project there. But yeah, I'm slightly involved with that at Lyft just because, again, since Envoy builds with Bazel, there's another repo that's also on the Envoy proxy GitHub org called Envoy Mobile. And the point of that is, instead of being a separate service proxy, it's shipped as a library with like the core of Envoy. And so the hope is that a lot of the same infrastructure that's already being built out on the server side for so many networking things can kind of be shared on mobiles instead of having to do that twice. So, I think a case that people are really interested in is Envoy's kind of filter chain, which probably I'm not the right person to get into on that either. There's tons of great talks about how Envoy works and what the point of it is and how it's useful on mobile. Even like there's some Envoy mobile talks out there if folks are interested. But yeah, that's kind of the goal for us, is to get a lot of the same technology that's happening in Envoy on mobile as well. And it's just an interesting thing that, it so happens that it overlaps pretty heavily with the rules and stuff, because now it has its own Swift library and this other Envoy mobile repo and stuff. So I've been helping out a little bit there too.
Is Envoy Mobile, is that used in the Lyft app, or is this something we shouldn't talk about?
No, it is used in the Lyft app. Yeah. So if folks are interested, they can definitely go and see what's happening on that GitHub org or in the Envoy, Slack and stuff. But yeah, it is used in the Lyft app. And they're, kind of hoping to build a lot more functionality on it over time. Right now, it's kind of in the earlier stages, and I think a lot of the promise comes from having it out where you could, maybe turn on Quick as a networking protocol if you want, because everything supports it, and you don't have to worry about OS constraints of it being used. So because it runs on both iOS and Android. So yeah.
Cool. And so it seems like Envoy Mobile is also an easy cross-platform kind of code sharing mechanism for you there too.
Yeah, it was one of the first, maybe it was the second, but we don't have many shared, kind of C++ libraries. It does have wrappers in Swift and Kotlin that are on top of that are part of Envoy Mobile itself. But yeah, it's kind of interesting because, yeah, Bazel's kind of the shared language in a lot of this stuff. We're not actually building Envoy as part of our build right now. We vendor an artifact instead because the Envoy build is pretty massive. So we found that to be the right decision so far. But it's interesting that theoretically in the future, we could integrate that more closely into our build and potentially get some, remote execution wins and stuff there too.
Yeah, It's great. And then I don't know if you're interested in just, or if you know anything about the state of the Android team at Lyft and if they've evaluated Bazel. I don't know if I've seen any blog posts or anything like that, but obviously Android is AOSP is building with Bazel, and that's exciting. Android apps, less of a clear cut win. And so, yeah, I'm curious if you have anything just to share broadly there.
Yeah. So our teams are set up at Lyft. So iOS and Android folks are on the same team. So my team also owns the Android tooling side and are in the process of migrating to Bazel on Android as well. I think that we definitely have high hopes about the wins we can get from sharing a lot of tooling and knowledge and infrastructure across platforms, because so much of it is generally applicable, even if even outside of the like how do you build an iOS app stuff, we can still collaborate, I think, a lot better than we could before by having that kind of shared tool. And again, we're just really optimistic about the future of Bazel, so we really think that that's the best place for us to be able to kind of add new features that we need as they come up from Google, or maybe Google adds them instead, but add new features, iterate on performance, all that kind of stuff. I think we're more optimistic about being able to do that in Bazel than anything else in the Android ecosystem for builds right now. So yeah, that's kind of in progress. Like you were kind of alluded to, there's some ambiguity in the Android community. There's, with moving the rules to Starlark and stuff like that. But we're seeing some progress on that these days, which is really great. Hopefully that all gets worked out, this year.
Cool. Yeah. And I imagine there would be some opportunity to share some code in terms of like, I don't know if you use like IDL or anything like that, like Share PC or Thrift, or some of those artifacts, of course, could be kind of shared. Would you move more towards like a mobile mono repo at that point?
Yeah, we've talked about that a lot. One thing that Lyft has never had to deal with, because in general, Lyft is like a heavily microservice and separate repo company. So like the mobile repos, so we have one iOS repo, one Android repo, are actually kind of the outlier for how much code, having a bunch of apps in the same place. So we're kind of intimidated by the potential challenges that we would be the first to hit around Git performance and all of that kind of great stuff. But I think that there are a lot of potential benefits in that. We have talked about it a lot. We're already at a point where they're far enough along on the Bazel side of things that we end up sharing tools. And right now we don't really have a great way to do that. I mean, we could split them into another repo, but then there's, you have the overhead of managing that stuff. So it's been something we've talked about. But yeah, on the code sharing front, if we were to ever go down the path of sharing more, shared C++ or Kotlin native or something like that, I think that there would be a really strong reason to do that. We are using protos and stuff right now, but because those are also used on the server, those come from a separate repo. So that's not really a benefit to us for doing the mobile mono repo. And we generate Swift and Kotlin from those with Bazel as well. But yeah, I think that that's an interesting path forward that we'll probably want to do at some point, just so we can share more things and more tools that we've written around Bazel.
And broadly, is Lyft, is it a Bazel shop yet? Or not really? Is it mostly just mobile and Envoy?
Yeah, mostly mobile and Envoy. So Lyft's core business is obviously the rideshare area. And so much of that is written in Python. That was kind of our first microservice language, like after the kind of monolith phase in the very early days. So a lot of Python folks, I don't think they're really feel strongly about integrating Bazel. Not that there aren't benefits, but obviously there's some overhead. I can't really say that I would recommend that we migrate to Bazel in over 1,000 repos or something, right? Like there's a lot of just tactical concerns there. And then besides that, we have some Go and stuff, but those people are pretty happy using the normal Go tool chain. I think that stuff works pretty well. But then kind of the fringe of other lines of business in Lyft, a lot of them are using Bazel. So our kind of like L5 autonomous car hardware stack is built with Bazel. It's a huge C++ project, absolutely massive. And then our kind of bikes and scooters firmware stuff is all built with Bazel as well, because there's a lot of tech there too. So that's also a lot of C++. So a lot of overlap with those folks. And we talk a lot at Lyft between ourselves. But yeah, we'll have to see if Bazel takes over more things. I think that, definitely we're hitting the kind of polyglot state. So there's a lot of languages at Lyft, and there are a few that are technically blessed, but still, there's a lot of outliers. And so I think there are some potential benefits, but we'll have to see how that evolves, because, it's a big migration or long way to go from lots of repos, lots of services, lots of Python to being something I think makes sense to have the Bazel integration.
Yeah, I think in general, like in terms of staging, mono repo probably would come first. And this is a topic that, I don't really care to get caught up in. It's a hot one. I think everyone has their preferences. Is that something that you guys have chatted about at Lyft, like the mono repo, and what's kept you away from that, if anything?
In the early days of Lyft, there was definitely some chatter about it. I don't think nearly as much lately. I think that we have some folks who have had negative past experiences from other companies in the monorepo world. Unsurprisingly, I think like a lot of companies in Silicon Valley, like we have a lot of folks who used to work at, Google or Facebook, and they have a lot of monorepo opinions. And I think a lot of different companies had other checkered pasts with that stuff too. So I think, definitely getting people to align on that would be difficult. That's kind of why I mentioned the Kotlin native thing for the mobile side too. Like I think you need a really good incentive like that at this point for us to consider moving to something like that. But who knows?
Gotcha. Cool. Well, great. Yeah, this has been good. So obviously, I think in conclusion, there's a couple things that I definitely want to touch on. So first of all, in the context of rules Apple and rules Swift, how might someone contribute if maybe they have something that they should start upstreaming that they've been working on, in their fork, or maybe there's, they just want to get involved more in the community. What's a good way to get started there?
Yeah, I would definitely, like we said earlier, I definitely recommend if people have forks or patches that they think are generally applicable, they should definitely submit PRs upstream. I think that we really are interested in making the rules work out of the box for as many folks as possible. So we're super happy to take contributions like that. I think if you don't really know where to get started, there's definitely a lot of, issues that could be solved if you want to go down that route, or you can, join the Bazel Slack. And, I think all of the maintainers are in that Slack. There's an iOS channel there. You can talk about stuff there, or you can reach out to me personally. I'm happy to talk about, kind of options for that too. But yeah, I think in general, we're really happy to work with folks in the community to, make Bazel better for everybody.
Cool. And where can people find you on Twitter?
Yeah, my Twitter handle is Smiley Keith, which is my last name and then my first name. I'm also on GitHub as Keith, which I'm very happy with. So, yeah.
Cool. And is your iOS team there at Lyft hiring?
Yep, not for the tooling team specifically, but yes, the iOS team is. So if you go to lyft.com/jobs, you can see the current iOS openings in lots of different places besides San Francisco if folks are interested.
Well, I assume it's mostly remote these days too, huh? Great. Well, cool, Keith. It's been great talking. Thanks for coming on the podcast.
Thank you.
Yeah, thanks for having me.
Thank you for tuning in to the Flare Build podcast. Please like, subscribe, and tune in again with Zach and Tatiana for the next podcast in the series.